Today we're going to talk about loss functions. Common categories for loss function are regression and classification. So we have this is regression, and then we have classification. So where's the difference between these two? Whenever your values are continuous, you're going to call that regression. Like for example, if we are talking about one of the most common example would be the price of the house. So it is a continuous value. You can't get any value in between. For example, something like size can be regression. If I have a axis like this, if I have a line like this, I can take any point on top of this line. So that means it is continuous. There's no separation between the value. But then when you're talking about the classification, you either have binary classification, which is true or false if it's cat or dog, or you can have multi-class classification. In fact, you can divide this regression values. For example, if we are talking about the size of the boxes, there are individual box size. So each one of them are going to be in separate class, because now it is true that size itself is continuous, but then when you have limited box sizes, then that is going to be a classification. So whenever you put each one of them in separate categories and you cannot choose any value between them, then you're doing classification. If you can choose any value, it doesn't matter what the number is, then you're gonna have regression. Today, I'm going to focus on loss functions for regression, and I'm going to talk about two common types of it, which is MSE and MAE. So I'm going to talk about this, and then later on we're going to talk about the type of classification. But today, let's focus on MSE and MAE. First of all, MSE stands for mean squared error. So that means whatever your value is, you are squaring it. You bring it to the power of 2. And then, but MAE is the absolute. So that means that your x is going, that means that it doesn't matter if your x is negative or positive, you're going to have a positive value. I'm first going to show you how are we going to calculate MAE and MSE, and then I'm going to tell you when you should use MAE and when you should use MSE. Okay, so when we're talking about mean absolute error, first of all, we have mean here. So that means that we are getting the average. If I have actual values, when I say actual, that means that the labels that we gave to the model, that means our label, and then the model is trying to guess the value. So the actual is the value that we gave. I'm going to put 3 random numbers here, 0.5, I'm going to give 2, and I'm going to give 10. And then for predicted, I'm going to give 1 for the first one, I'm going to give 4 for the second one, and for this one, I'm going to give a 10. So now when I want to calculate my mean absolute error, I'm going to say I have 3 values. It's absolute, so it doesn't matter which one is positive or negative. It's going to be a positive number. I'm going to say 1 minus 0.5 is going to give me 0.5. And again, I don't care because I have absolute value. And then I'm going to say 2 minus 4 is going to give me a 2. And 5 minus 10 is going to give me a 5. Here I'm going to get 7.5. 7.5 divided by 3 is going to give me 2.5. Okay, I'm going to take this off because I want to do MSE here. So since we are squaring here, it's always going to be positive anyways, okay? So we're getting the same numbers, but we're going to square each one of them. Now, if I square 0.5 is going to be 0.25. So it actually got smaller. 0.25. And then when we have 2, we square it, we're going to get 4. And then when we have 5, we square it, we're going to get 25. Again, these are all going to be divided by 3. And now I'm going to get 9.75. Our error is going to be bigger than what we got from MAE, but this is not always the case. Here it's getting very confusing. So I have 0.5 plus 1 plus 0.25. So this value, when it's going to be divided by 3, you got the absolute, so it's going to be 1.5 and then 1.75 divided by 3. And then for when you're going to square it, this value is actually going to get smaller because you're doing 0.25 plus square of 1 is 1, and then square of 0.25 is, I guess, 0.125. So divided by 3, it's going to give you 1.38 divided by 3. So as you can see, this value is smaller than this one. So now that we see this, let's actually plot it and see the comparison that way. So now, if I want to plot it, for example, 3 is the correct value. If I want to plot it, I'm going to draw MSE with purple. So MSE is going to be something like this. And then when we want to plot the MAE, which is absolute, I'm going to draw it with white. So it's going to be something like this. So now what are we learning from this? This shows that when you're using MSE, as your errors start increasing, you're going to apply more penalty. And then when you have smaller, it's going to increase smaller, and then when you're getting bigger, it's going to increase so much. So it's going to make a shape of a bowl, but this is going to be a very open V. We care about this for multiple reasons. It's completely dependent on what you're trying to do. Now you understand the characteristics of MAE and MSE. In general, you just want to think about what you're trying to do, and then you will choose between these two. But one of the things that you want to consider is about outliers. Okay, so MSE is more sensitive to outliers than MAE is. For example, if you're talking about temperature and you have taken out all of the outliers, at that point, it doesn't matter if, for example, it is 12 degrees or if it is 14 degrees. These are very close. So you don't care that much and you don't want that drama. So you're just going to use mean absolute error. Those two values are going to be close to each other and they're going to be less penalized. But then when you're talking about something like medical diagnosis, for example, blood pressure, now your outliers are actually true values and you care about them. You want to put more attention on those values. So for example, if somebody's blood pressure is very high, but then your model decided that is the but your model decided on a normal blood pressure, then you want to penalize that. You are failing to diagnose that.